No it don't! No it don't!
Minutes to do this. Okay, so horizontal asymptotes, before you actually understand it, you need to know what an asymptote is. And the best way to show you that is through a basic graph you probably learned in grade 12. And this graph is called a graph I guarantee you, probably maybe 4 of you will get this question right. I want you to draw me the y equals to 10x graph. Go. I'm going to pause it, let you lost. If you need a little hint, I'll give you hints. There's these magic markers. First one is at pi by 2. Wow, well done. You remember. Hot shot. So what's the next one at? 3 pi by 2. And finally 5 pi by 2. Those are called my magic markers because they actually start defining what the shape looks like. So go ahead and do that. There we go. So at these points, these are called your vertical asymptotes. Okay? Now a lot of you did this in grade 12. And what your graph looks like is it looks something like this. It looks go down and goes down like that. Goes down like that. And notice what I want you to focus on is my graph never touches the asymptotes. Problem is, this is known as your vertical asymptote. Asymptote. That's a vertical asymptote. Every one of you work with that in grade 12. You vertical asymptotes. Very few of you work with something called the horizontal asymptote. See, in a vertical asymptote, the graph never touches it. So it follows along but never touches it. So if I were to give you this graph, let's say y, we'll call this graph, I'm just going to make it up. Right there, right there. I want you to tell me what is my horizontal asymptote going to be. Asymptote. Okay. A horizontal asymptote, think of the same thing as vertical, except this time the line is horizontal. There's the imaginary horizontal line that your graph will never ever touch. That's called the horizontal asymptote. In this case, you need to look at the graph and say, where is it going to be? Say, Nick, do you have an S? Yeah, I guess. Y equals to 0. Because there's a little horizontal asymptote here. So I want you to go ahead, draw in a little horizontal asymptote right on the line. And I'm going to make a dash to show that there is a horizontal asymptote. When y equals to 0. Okay. That's easy. If I give you the graph, you can find the horizontal asymptote. But the problem lies in, what if I don't give you the graph, I give you an equation? So in order for you to understand horizontal asymptote, notice one thing. When x approaches some magic number, see, when x approaches, no matter what the magic number is, the graph f of x will equal to some value. We'll call this magic value L. It's like approaching it, but it never equals to. Problem is, that's what horizontal asymptote is. Oh, you actually saw the picture. What goes in here then? When x approaches what? It's not 0, not h. What's the value? Because it goes all the way to infinity. So Manat says, hey, so isn't that the limit? Horizontal asymptote really is called limits. So we go back to the concept. So I took this concept as x gets bigger and bigger and never ends. I want to see what the graph really approaches. And if there is such a limit, so we call that lim. As x approaches infinity of f of x equals to L. Okay. Or, notice one thing, the graph can also go in the opposite direction. So notice the graph can go in the opposite direction. Lim as x approaches negative infinity of f of x. That equals to L. Okay? These L values are called your horizontal asymptote. Asymptote. So now we go back to our limits, what we did in chapter 2. Working with limits again. I'm going to start off with an easy question. Lim. As x approaches infinity of x. Solve it. I want you to graph the shape. So this x really is f of x. That's f of x. What is the limit as x approaches infinity? Remember? Infinity? It's correct, because all I do is just sub in infinity, which becomes infinity. So which means there's no, I'm going to use the term ha for horizontal asymptote. There's no ha in this one, because there's infinity. And I can prove it to you by drawing a graph. Y equals to f of x. Well, y equals to f of x is a simple straight line that goes through the origin. And that's the reason why there's no horizontal asymptote. Simple. Say, hey, Mr. That was pretty easy. What if I give you this? And this is find ha for f of x. And here are your choice. I'm going to give you a f of x equals to. I'm going to start off with a really simple one. 1 over x. B f of x equals to 3x squared minus x plus 2 over 4x squared plus 99x plus 9,999. Let's see who can figure this one. How many of you did horizontal asymptotes in grade 12 before? Hands up. It's about a few of you did. I want to see what you remember from this. So I'm looking for the horizontal asymptotes. Really, which means, here we go. Number 1. Well, if I go lim as x approaches infinity of 1 over, if I sub in a really large number, 1 over a million really approaches 0. So it's very simple. This is a key concept you need to understand. 1 over infinity will always give you 0, or the limit. We call that as it approaches 0. The problem lies with this one. Grade 12. How do you do this? And I believe only Karin got, who else think they have the answer for this one? Here's how you do this. So let's write this down, guys. Limit as x approaches infinity of 3x squared minus x plus 2 over 4x squared plus 99x plus 9,999. Now, some of you say, Mr. that 9,999, here's a little cool fact. My infinity is such a large number that the only thing I should focus on is the highest power of x on the denominator. Okay? So here's the actual proper way of doing it. We look at my denominator. I'm going to highlight denominator right now. We focus on the highest power of x, which would you agree is this x squared right here. That's what we're going to do. We're going to focus on this. This is what matters because a million to the power of 2 is so big that everything else doesn't matter. That's why we focus on that. What we're going to do is we're going to divide everything by x squared. So you're going to divide the whole entire equation by x squared. So I'm going to divide the first number. So let's do this. 3x squared over x squared. See? I'm not dividing by 4. I'm just dividing by the highest power of x. Minus x over x squared. Plus 2 over x squared. All over 4x squared over x squared. So this is a quick review of grade 12 plus 9,999 over x squared. If I were to simplify, I would get 3 minus 1 over x plus 2 over x squared all over 4 plus 99 over x plus 9,999 over x. Now, this is a limit question. Would you agree? What's going on? Oh, x squared, yeah. Hey. Would you agree this gives me 0? Because we just did this from the top. 1 over some really large gives you 0. 2 over some really, really large number will also give you 0. I want you to go ahead and do the bottom for me, please. Go. So do the bottom right now. 99 over a trillion. Well, that's easy. That's also going to give me 0. It doesn't matter how big this number up here is. This will always give you 0. So the limit is really 3 over 4. And that's called my ha. So I have a ha at 3/4. That is how you're supposed to do the horizontal at the proper way. Try this question. Somebody say, hey, Mr. That was fun. I know it was fun. Try this. F of x equals to 2x squared plus 1 over 3x minus 5. I'm going to posit a key. Remember, key is the highest power in the denominator. In the deno. That's the key. I don't look for the numerator. I'll focus on the denominator. I'm going to let you... If I look at the denominator, so here's a hint. The denominator is x, so I'm going to divide everything by x. I'm going to start with the bottom first, because the top is a bit tricky. I'm going to leave the top the way it is for now, 2x squared plus 1. I know I'm going to divide by something, 3x. I'm going to divide everything by x. See? Minus 5 over x. Here comes the tricky part. If I'm dividing everything on top by x, which means I'm dividing this by x, I'm dividing this by x. But the issue is here. This is not x. Because when I bring x from outside the square root to the inside, Neville's, what does this become? This actually becomes x squared. Because the square root of x squared is an outside x. So if I want to bring x inside the square root, it actually becomes x squared. So guys, you can finish this on your own now. Go. But remember, this is lim. As x approaches infinity. So figure out what my ha is. Go. If I did this correctly, you should get 2 plus 0 over 3 minus 0 gives you root 2 over 3. Ta-da. And that is my ha. Horizontal asymptote. One last question, and this will wrap it up. And f of x equals to x squared plus 1 minus x. If I were to sub in infinity right away, some of you say, Mr. That's easy. That's infinity minus infinity. That gives you 0. The answer is no. Wrong approach. What about this one? If I look at this, the first thing you're going to have issue is, where's the denominator? The deno is missing. Because there should be x in the deno. This is just a simple polynomial. Question is, how can I turn this so that x is in the denominator? It's a trick you learned in grade 11. That's a trick you learn in grade 11. Starts with an R. Rationalize the denominator. In this case, I'm going to multiply by the conjugate. So B. So there's a lot of tricks in calculus they don't teach you about. And they expect you to know this just by looking at it. We're going to multiply by the conjugate. When we do that, what happened is we have ourselves a denominator. Go ahead and multiply it out. And notice one thing. I'm going to multiply out the top parts. Okay. So when you multiply this out, what you created is something where you can actually divide now. If you multiply this out, you should have f of x now equals to x squared plus 1 minus x squared all over x squared plus 1 plus x. Now, I leave this up to you. What are we going to divide by? Okay. Oh, whoa. Which x squared? Oh, yeah, you could. So this becomes 1 over x squared plus 1 plus x. And remember, this is lim as x approaches infinity. I look at here, x seems to be instead of x squared in the inside or x. They're really the same thing. So I'm going to divide this by x squared, and this by x squared. Because when I bring x on the inside, it becomes the squared. Okay? And the top too. So this becomes 1 over x all over 1 plus 0 plus 1. Right off the bat, you should see what your answer is already. 0. Because 1 over... This is the key right here. 1 over x always gives you 0. So my answer really, I have a ha at 0. And what you use to complete it is your ha lesson. Your work for today. Page. So is it that hard? Nah, not really. It's kind of fun. Page 261. Numero 3, 4. I want you to do 7 to 25 odd. Or you can try even, up to you. If you use even, use later. If you use odd, you can use book. But that is it, guys. You can't do vertical asymptote yet. I will show you that next time.